Weight decay is a regularization technique which lets us control the generalization of the learning algorithm by adding a criterion to the minimization target that expresses a preference for the weights. Let's have a look at an example of using this method. When performing the linear regression without weight decay, we minimize the mean squared error on the training set. By doing so, weights can take on any value that minimizes the training error. This may lead to overfitting. With weight decay, we can express the preference for the weights to have a smaller squared Euclidean norm by adding the squared L2 norm of the weights to the minimization target. Now, the minimization algorithm must also consider the minimization of the squared Euclidean norm of the weights. Lambda here determines the strength of the preference. Larger the lambda, stronger the preference. Let's have a look at the graphical illustration of what effects does the lambda have on the generalization. The red points on this graph correspond to the training points, and the purples correspond to the testing points. The blue plot is the result of an 8th degree polynomial regression with L2 regularization where lambda equals 0. Essentially, by multiplying the preference criterion by 0, we don't have any preference and the model overfits. The green plot has a more optimal value for lambda. For an 8th degree polynomial, it generalizes well for this task given this dataset. For the orange plot, the preference for smaller weights is too strong, so the minimization algorithm mostly only cares about minimizing the weights and does not care much about the error.